Okay, so today is our second day of the curve sketching unit, and we're going to be looking at the second derivative test. First derivative test, remember, gives us critical points, and when we set it to 0, that's where the curve is flat. So that's critical points, max and mins, and things like that. And we use it to find areas of increase and decrease as well, and maximum and minimums. Today we're going to look at a second derivative, and it tells us two things about the curve, and we're going to be using these two derivative tests to find traits of the curves. So we'll do an example today, maybe one or two examples, maybe one, and then tomorrow we'll get into a little more complex examples, which using both the first and second derivative tests. So this will be part one of this. So let's go ahead and say what the second derivative test for a polynomial curve will tell us. And what the second derivative means basically is you take the first derivative and you do a derivative again. And so the second derivative test tells us two things. First thing it tells us is that when the second derivative is set to 0, the point, and then you solve for x. Solve for x. The point is known as an inflection point. Of the curve. Okay, and what is the inflection point of the curve? Well, that is the place on the curve where the concavity of the curve changes. Okay, so let's draw a little picture so we know what we're talking about here. So what we're talking about is something like this. Okay, so if I had just a regular curve like it went up and down like this, like a cubic equation, that place in the middle right there where it goes from being opening downwards like that to opening upwards like this is called your inflection point. Okay, I will use IP to represent, just like I use CP for the critical points. IP can be the inflection point. So this is concave down. And this is concave up. Okay, you can also have it the other way like this. You would still have an inflection point in the middle of E. So concave up, concave down. So that's what an inflection point is for a curve. Second derivative, if you set it to 0, it gives us the point where the concavity of the curve changes. Okay, so you can see that it's kind of usually between a max and a min, like this is a max here and that's a min here. That's a min here, that's a max there. Okay, the other thing that the second derivative can tell us, and we don't always have to use this particular test because there's many ways to find max and mins, is this, B. When you sub in the critical point, the x value of a critical point, into the second derivative, So critical point. So when you sub in the x value of a critical point into the second derivative, okay, and I can't type this today. The answer sign tells you whether, or tells you if you have a max value or min value. Okay, and it's kind of opposite of what you think. If the second derivative is positive, the critical point is a minimum. Okay, so it's kind of opposite of what you might think. If the second derivative is negative, okay, this is when you're subbing in the x value of the critical point. The critical point is a max value. Okay, so how we do that algebraically, sometimes it's stated with function symbols. So you can say might see it something like this in a book. Okay, you might see it. So let's move that up just a little bit there. Okay, so if I said we had a function f of x, and if we took the second derivative, so use 2 primes to represent the second derivative, and if it was pardon me here, if we plugged in a value, let's say c for critical point, c is a critical point x value. So if we plugged it in, okay, and if that was greater than 0, if that was positive, we would have a min value. Okay, if we plug it in and it's less than 0, we have a max. Okay, and b is a critical point value as well. Okay, so that's basically what the second derivative will tell us. Okay, let me get my timer on here so that I can time us today. Okay, so what I want to do then is I want to do an example of find the max and min points using the second derivative and find any points of inflection. So let's do that today. So using the second derivative to find IP values, and let's say max and mins. Okay, now we don't often use second derivative to find max and mins all the time because we can find it by just using the first derivative and looking at our sign analysis. But this is another way you can do it if you want to, or to check your work, something like that. So let's do an example of this. Let's see, get my little list here for fairly good. Okay, let's do a very simple one to start. Let's say we have y equals x cubed plus 3x squared. And the question is, use the second derivative test to find IPs and the max and min. Okay, so that's just what we're going to do. Let's go to marker here. So step one is to take the first derivative to get our critical points, because we need to know where the max and mins are going to be, and that comes from the first derivative. So let's go with blue here this time. So step one, find critical points using the first derivative. Okay, so that's pretty easy. Y prime is equal to 3x squared plus 6x. Okay, so we're going to set that to 0 to get our critical points. And we've got our first critical point here. We got 3x coming out of there, x plus 2. So 3x can equal 0, and x plus 2 can equal 0. And we've got x equals 0, and x equals negative 2. There's our two critical points. Now, we could just plug those into here and find if they're a max and min. That'd be easy, right? But if it was a really long equation, say it was 15 terms or 6 terms or something, we might want to try the second derivative test instead, okay, to do it. So we're going to do that here and see whether you have a max or min here at each of these without plugging them back. So step 2 then is to find the second derivative. Okay, and then we're going to set it to 0 to find an IP. Okay, so take the same equation we had for the derivative and we derive that. So we call second derivative, we just put 2 primes. Okay, so we got to go 2 times 3 is 6x plus 6. Okay, so then if we set this to 0, we get 6 times x plus 1. Okay, divide by 6 on both sides. So x equals negative 1. This is an IP. Okay, so we have an inflection point at that IP value. Okay, so now all we have to do is test the critical points to see if they are max or mins, and then find out what the inflection point is. So step 3, test each IP, or not IP, pardon me, critical point CP into the second derivative. Okay, and then you'll find if it's a max or min. Let's do that. Okay, so our second derivative is y prime prime equals 6x plus 6. Okay, so now we're going to put in 0. Y prime prime equals 6 times 0 plus 6. Y prime prime equals 6. It's a positive 6. So there is a minimum at x equals 0. Okay, and then we do the second one. Y prime prime equals 6x plus 6. Now we're going to put in negative 2. 6 times negative 2 plus 6. So this is going to be negative 6. So we have a maximum at x equal negative 2. Okay, and our inflection point here is at negative 1. So we can go y, we got to go back to the original equation this time, equals x cubed plus 3x squared. If we want to find the y value here, we can put in the negative 1. Negative 1 cubed plus 3 times negative 1 squared. So this is negative 1 plus 3. So this would be 2. So our IP is negative 1 and 2. Our minimum is at x equal negative 2. We could figure out what it is if we plug it in. If we want to, we can figure out what this is. If we want to, the minimum is going to be 0, 0 if we plug, 0, 0 if we plug it back into here. And if we plug in negative 2 into there, this would be negative 2 cubed, which would be negative 8. And then this would be plus 12, so it would be negative 2 and 4. We could figure out the numbers. That's why sometimes the second, but if you didn't know the numbers, you just did a second derivative test. That's a quick way to check to see if it's a max or min. Another way to check your results. Okay, so if we wanted to find areas of concavity, which is something else that we'll do more regularly, that's what we're going to do next. So this is something that these types of questions don't often ask them, but because we can do max and mins another way, I do ask to find IPs a lot though. This is the main part here, finding the IP. This part here of finding if it's a max or min, you can do it various ways. So that's just another way to do it. So let's do one more example here of finding, we'll do it on the next page, of finding some concavity, let's say. Okay, so let's say we want to find, in this example, I'll use a different curve here. Let's see if I'll find one here. Okay, let's use this one. Let's do a bigger example 2. Finding intervals of concavity. And let's say regions of, well, let's just do that. And IP points. Let's not put too much into it. We'll do the whole curve analysis thing tomorrow in our second day. So let's say we have, that one has fractions. I'm going to save that one for tomorrow. I'm going to do more examples of a full curve sketch. This one has fractions too. We'll save those two for tomorrow. We'll do less complexed one here. Okay. Let's say, well, let's use the exact same one. Y equals, what was it, x cubed plus 3x squared. Okay, same curve. We'll do more complex stuff tomorrow. We'll actually do a whole curve sketch, like use the first and second derivative tests and find all the traits that we need to do, and then sketch a curve as well. So let's say I have the same thing I had over here, and I already know what the IP is because we figured it out. Okay, but how do we find out whether it's concave up or down? Well, that's pretty easy. Okay, so let's say that we did, oops, wrong pen. Okay, so we already figured out what y prime was. And we already figured out what y prime prime was. And we figured out that if you set this to 0, so that we got an IP at -1 and 2. So we figured out, because when we plugged in -1 here, so this was -1 plus 3, which is equal to 2. Okay, so now all you have to do to figure out is put your IP -1 in here, and then all you have to do is take your second derivative test, or your second derivative factor, which is 6, which is constant throughout. 6 is always positive, but you have x plus 1 here. It's 0 right here. That means that's where the concavity shifts. 6 is always a positive number. Okay, and then this is negative here, and this is positive here. So that tells us that this is negative here, and this is positive here. So this is concave down, and this is concave up. And that's, so if we were to put the region here, it's concave down from -infinity to -1. And this one is concave up from -1 to +infinity for this particular curve. So finding the area of increase or decrease is pretty straightforward. Okay, I'm going to find another one, and we'll do one more today, and then we'll do curve sketching tomorrow. So let me just pause this to find one that'll fit, and I'll be right back. Okay, so I just, our last example for today, then we'll do curve sketching tomorrow, which is more what we'll be doing using both. So find the critical points and the inflection points in the areas of increase and decrease using the first derivative test, and the area of concavity using the second derivative test for that. So the first thing we're going to do then is find the critical points of this. So we're going to do y prime. So that's 1/4 times 4, that's 1. So this is x cubed minus 3x squared. So we're going to set this to 0 to get our critical points, and we take out x squared. This is going to give us x minus 3. So we have a critical point, x squared equals 0, or x minus 3 equals 0. So x equals 3, or x equals 0. So we have our two critical points, so we can do our 0 here and our 3 here. First derivative test telling us whether it's increasing or decreasing. Not two zeros, Rob, just 0 and 3, pardon me. There we go. So here's a critical point, there's a critical point. We can plug them back in, one 0, 0, and the other's whatever you get with a 3. Okay, so let's do increase, decrease. So x squared, well, we know that x squared is going to be positive all the way through. It's going to be 0 there, but positive all the way through. Okay, x minus 3, it's going to be 0 over here. Okay, so this is decreasing, decreasing, increasing. So it decreases from negative infinity all the way to 3. And it increases from, let's see here, 3 to positive infinity. Okay, so we don't have a max or min here. We just probably have an inflection point here because we don't have it changing, but we go from negative to 0 to positive. So negative slope to 0 to positive. So this is going to be a min. Okay, and we can check that later. Okay, so now we're going to do the second derivative test to get an inflection point. So critical points can be max or mins or inflection points. So second derivative, y prime prime equals, okay, so we had our first derivative being right here, 3x cubed minus 3x squared, or sorry, not 3x cubed, x cubed minus 3x squared. Let's keep it in view first so I don't mess it up. X cubed minus x cubed minus 3x squared. That was the first derivative. So now we can do the second derivative test. So this would be 3x squared minus 6x. Is our second derivative, I guess. We're going to set this to 0. So we can take out 3x. Okay. And then we have x minus 2. Okay. So then we have 3x equals 0. And we also have x minus 2 equals 0. So this is x equals 0 and x equals 2. We have IPs at both places. Okay. So if we want to get what our IPs are now, whether it's concave up or down, we can do analysis of the second derivative. So we've got a 0 again and a 2 this time instead of a 3. Okay, and we have x squared again, or 3x, pardon me, not x squared, and x minus 2. So this is 0 there, and this is 0 here. 3x is negative here, because it's not squared, right? And positive here. Oop, I forgot to put the positive after the 2 here. Okay, so this is positive, this is negative, and this is positive. So it's concave up from negative infinity to 0 and 2 to positive infinity. And it's concave down from 0 to 2. Okay, and then tomorrow we'll get into how you use this information to do a full curve sketch. Okay, this is just, if you wanted to find these two IPs, what the actual points were, you could plug those into the original equation and get them. I guess I did say, what did I say in the beginning here? Find the critical points in the, okay, so the critical points, if we put in 0, we get 0, 0 for one critical point. Say 1. If we put a 0 in there, and if we put 3 in there, so if we go 1/4 times 3 to the 4th minus 3 to the 3rd, we figure this out. Okay, so a little bit of calculator here. 3 times 3 times 3 times 3, 3 to the 4th. Divided by 4, or times 1/4. Minus 3 times 3 times 3, which is 27. You get negative 6 3/4, or if you like it in fraction form, negative 27 over 4. So our other critical point was 3 and negative 27 over 4. There's our two critical points. Let's do our two inflection points. Okay, remember, you have to plug it into the original equation. So the original equation, that's 1/4 x to the 4th minus x cubed. So let's write it here. Okay, so if I want this one at 0, you know what? That 0, 0 is an inflection point. It is also a critical point, but it's also an inflection point. So critical points can be inflection points as well. We already figured that one out. This 2 we haven't figured out. That's an inflection point. But what is it? Y equals 1/4 2 to the 4th minus 2 to the 3rd. So 2 to the 4th is 2 times 2 times 2 times 2, which is 16, times, or divide by, 4, which is 4, minus 2 to the 3rd is 2 times 2 times 2, which is 8, which gives us negative 4. So we have another one at 2, negative 4 is second IP. Okay, so that's using second derivative test, first derivative test a little bit as well to find critical points. We're going to stop there today. That's almost 35 minutes, sorry. Tomorrow we're going to spend doing a full curve analysis and sketching a curve. To do that, we're going to put everything together, and we may spend a full day on that, and then before we get into practices. Okay, so this type of stuff that we did today using the second derivative was more expository type stuff. Specifically, the questions that I'm going to ask you on the hand-in is to sketch the full curve. So you'll be doing what we're doing tomorrow, which will incorporate what we learned the day before and today into one thing. So that'll be the main focus. Remember, there's no quiz in this unit, it's just a hand-in. And then the next unit will have one curve sketch on it. Okay, so tomorrow will be curve sketching, and we'll focus on that. And then the next day after that will be practice.